Hello, my name is Jeff Boyar. This is my graduate project for Python for Data Science in the Harvard Extension School for E29, focusing on predicting bike share demand. This course was offered in spring 2018 with the following staff. My project is focused on visualizing bike share demand for the Capital Bike Share program in Washington, D.C. That's going to be based on specific variables like time, so day, month, or season, as well as weather, and then also predicting using machine learning the hourly bike share demand based on the same variables. Required libraries are as follows. Okay, so I was inspired to do this based on my own use of the Boston Hubway bike sharing system, and this is based on a Kaggle competition. As you can see, I imported different data manipulation libraries as well as different graphing libraries and various machine learning libraries, specifically linear regression libraries like Ridge, linear regression, Lasso, as well as attempting to look at the decision tree regressor. First, I wanted to outline and read in the data, as well as define what each of the variables are based on the Kaggle competition. I didn't see any null values or missing values in my column, so I didn't need to clean any of the data. However, I did notice that one of the time variables was an object, so I needed to convert that into a date time object in order to be able to capture various elements of that date time object. So I was able to create an hour, day, and month variable. Next, I wanted to plot various aspects of the demand based on different variables. So here I wanted to look at, for each hour, what the total demand was, or the average bike use was per hour. The blue column, or the blue line, you can see is the total amount, whereas the green is for registered users, as well as the orange is for casual users. You can see that the trend for registered users is more similar to the total, whereas casual users has its own trend pattern. I also wanted to see how bike use changes based on day of the week, 0 being Monday, 6 being Sunday. Flat demand over the days of the week, whereas it dips in the weekends for registered users, but actually increases for casual users. I also wanted to visualize bike demand for the months of the year, again broken up by registered, casual, as well as total. Here I plot average bike use by humidity, so looking at a weather variable. So you can see that as the humidity increases, bike use actually decreases. Here we look at temperature. So as temperature increases, bike use actually increases, except for a drop off after a high temperature. And this is a wind speed variable, so the increase in wind speed, how that impacts average bike use. It looks relatively flat. Here I look at a coding variable for weather, so whether that was good, okay, poor, or bad. And as you can see, so for bad weather, we actually get a dip in bike use. So based on my review of these graphs, what I wanted to do was create various dummy variables to help the model. So I created a variable that broke up good weather. So if it was a 1 or a 2 coded, I gave it a 1, and if it was bad weather, I gave it a 0. I also created a dummy variable for high temperatures to capture the drop in demand after high temperatures, as well as low humidity, where looking at the graph you could see that there was actually an increase in bike use when humidity was low, but a decrease when humidity was high. I also wanted to separate out various dummy variables for the different times of the day, so trying to break it up instead of by hour, but actually trying to group them together. Finally, what I did was some one-hot encoding to get dummy variables for some of my ordinal data, like hour, day, month, or season. As you can see, I have a lot of features now. So in order to predict bike demand, I separated my data into features and targets, dropping some of the variables that were not necessary for features and using the count or total bike demand for my target. I split the data into training and testing data, and used various regression models to check my features. So as you can see, my model is not performing very effectively. However, I did see that my lasso model had the best mean R-squared value after doing a cross-validation score. So in order to try and adjust the results, or try and improve the results, I should say, I decided to remove some of the features in the lasso model. So remove some additional features, specifically the ones around the time of day, and that helped improve the model, but not by significant amounts. So if I had more time, what I would want to do was try and do some type of feature reduction using something like a PCA or a decision tree in order to determine which components are the most important to the model. I also could potentially separate registered users and casual users in the model. So as we saw in the visualization before, there's clearly a difference in the trends or the patterns for casual users versus registered users. So I'd want to figure out a way of modeling those separately and then combining them into the final model. And last but not least, I think there's probably other ways of doing this besides using a linear regression. I created dummy variables for the different data in order to be able to model these nonlinear relationships, but I believe there's probably other ways of doing so. So finally, I just want to show the different data sources. You can find the data source on my Kaggle or on the Kaggle page. I did find some help on the creating dummy variables at this link. As well as some information on the decision tree regressor, but also a lot of help from the E29 lecture and section notebooks. So that is my presentation, and I hope that you enjoyed it.